Good day. This presentation is about the comparison between the ABB sensorless synchronous reluctance machine drive and a custom drive with a position sensor. So this presentation is brought to you by Kodakwashe Mkurunge and
Poshogo Blondie.
Since our project considers the comparison of two drives, here we have the ABB drive from the manufacturer and also have the custom drive. Our custom drive uses the position sensor which is attached at the back of the synchronous reluctance machine. This is the machine. So one of the performance criteria that we're going to consider is the torque. So we're going to use the torque sensor or the torque transducer which is attached between the shafts of the two machines. So in order to get the torque, we're going to have to load the machine. So to load the machine, we're going to use the DC machine where the generated power is supplied to the load resistance bank.
So here is our vector control model inside Simulink. Our model consists of a speed controller. The speed controller measures the error between the command speed and the measured speed. This error is then reduced by the PI controller. The PI controller produces your Q and D reference currents. These Q and D reference currents are then transformed into the stationary three-phase currents through the inverse Buck transformation. The stationary reference currents are then compared to the measured current by the hysteresis current control, which then produces pulses that are being fed to the inverter so that the measured currents can match with the command currents. Here is our model inside the D-Space control desk interface. So here we're going to change our command speed, and as can be seen, our reference currents and the speed of the motor changes. Here are the key findings of the lab project. Firstly, there is little difference between the torque and speed response of the drives. However, if we look at the current inputs of the motor and the low torque requirements, we notice that if we're using the ABB drive to control the motor, we get high current inputs at low torque loads. This means if we operate the motor using the ABB drive at low torque loads, losses are expected in the motor, affecting the lifespan of the motor. Looking at the efficiency, the custom drive provides high efficiency in all load conditions. This is mainly due to the torque per ampere method being used in the custom drive, which means the custom drive is most applicable to the industrial application where the load requirements are varying slowly or are even constant.